Hey, grade 9s. So here's an example on dealing with something called algebra tiles. You've seen the algebra tiles already. So I'm going to ask you questions like that on the test. You'll see them on the exam. Some people like them, some people don't, but it's a nice tool to have to understand polynomials. So I've got an example here that I would like to work through with you. If you already know how to work through these, maybe you can pause the video and try it as an example on your own. We'll see if we get the same answer at the end. So we have to remember each of the tiles represents something. We have these big squares over here. These are going to be representing our x squared. We have these rectangle tiles over here. Those are going to be representing just our x. And lastly, at the very end, all the way over here, we've got our singular small boxes, and those are just ones. Now I'm using x as an example of a variable. You can choose any letter you want. You can use any symbol. It doesn't really matter. It's just in polynomials, we just use x. It's not a very commonly used variable in other fields of science, so that's what we use in polynomials so much. Now the other thing to remember is there's always going to be two different colors for the algebra tiles. You could either have a white one and a shaded one, kind of like what we have over here. The white ones are positive values, the shaded ones are negative values. You could also see red and yellow. Red will be your negative, yellow will be your positive. I'm sure you can see some other colors as well. I've seen some textbooks do blue and green. To be totally honest, I don't know what the difference is between those two. I just know the red, yellow, and the shaded and the unshaded ones. So we're going to work with some shaded and unshaded ones here and try to solve the problem. You'll notice that I have a combination of both for every single type of tile. So we have to clean it up a little bit to understand the question a little bit better. Now, anytime you have a shaded tile and an unshaded tile, they end up canceling each other out because they equal the exact same thing, just one is positive, one is negative. So up here, I've got an unshaded tile, and right next to it, I have a shaded tile. So those two can cancel each other out. You might notice that I still have a shaded tile and an unshaded tile, so I can cross those ones out as well. Okay, and the picture I have left for my big squares are two unshaded tiles, so that's what I'm going to write down. All right, now we move on to the rectangles. I've got 6 of them in total, and half of them are shaded, half of them are unshaded. So as long as somebody has a partner, I can cross them out. I've got one cross out here, one over here, and would you look at that? We crossed out every single one of our rectangles, and that can happen sometimes. It just means you don't have any rectangles in your final answer. Now we're moving on to the single units. I've got 3 of them, 2 of them are shaded, 1 of them is not. So I'm only able to partner one of them, cross them out, and I'm left with 1 shaded unit. And that's what my answer for my picture would be. To make more sense of it though, we can convert it back into a polynomial. Remember, the big ones are going to be a squared variable, x squared for example, and I have 2 of them, so I'm going to say 2x squared. My unit is always going to be equal to 1 depending on how many I have. I only have 1, so I'm only going to write 1, and it's shaded, so it must be negative. So my final solution is 2x squared minus 1.